Okay, we're going to be talking now about the volume of pyramids. So as in all of my volume videos or problems that we've been looking at, I try to define what volume actually is. So my basic definition that I think I'm going to have to modify a little bit is that it refers to the amount of space inside an object. And I say I have to modify it because this definition would have to assume that the object is hollow. And objects aren't always hollow, sometimes they're solid. So volume can also refer to things that are solid. Or maybe if you want to think about it like a hollow thing, like a container, it's filled up, so now it's solid. And that's one way of looking at it. So you could have like a block of wood, a cube of wood. You could imagine that it was hollow, but it just got filled up with wood. It is solid, right? It's completely full of wood, right? Or whatever, it could be ice or cement. So I guess the other way of defining it could be that volume is the amount of space that a solid figure takes up, okay? That it fills space, right? Okay, anyway, hopefully by now you kind of get the idea of what volume actually is. It can be something that can be filled up or something that just is already full, solid, and it takes up space, okay? Now, the formula for the volume of pyramids has components from previous formulas that we've already used and seen. And well, as we do more of these kinds of formulas, when we're talking about area and volume of different shapes, you'll start to see things repeat themselves. You'll start to see similarities that are always constant, you know, like, well, for example, let's just take this formula and break it down and see what we've seen already before. So we've already seen L times H. Can you see that? L times H. Maybe I would have said base times height. Some people refer to it like that. But basically we're multiplying two dimensions, and they're very straight dimensions. They're not round things, right? We know that when we're talking about circles, we have to have pi somewhere in the formula. But this one's just, you know, if I just said L times H and just forgot about the rest, what would that formula be for? Hopefully you guys are understanding now that if you're only multiplying two dimensions, we're talking about two-dimensional figures, and that means area. So that L times H would be the area of a quadrilateral, okay? And that could be a rectangle. Quadrilaterals are rectangles, squares, parallelograms, so those kinds of things, a rhombus, whatever. Things that are squarey, you know, maybe rectangular, but, you know, kind of four straight edges and that kind of thing, for the most part. Of course, parallelograms are rectangles that got leaned over. And anyway, we've already used length times height, and then we added another component. We added a third dimension. We added width, and now it's length times height times width. What's that formula for? Right, that formula is for the box, right, or a rectangular prism. It could be a cube, a perfect, you know, where everything measures the same kind of box, or it could be a longer box like most typical boxes are. And or a solid, like I said before, but we've used that formula, right? So now we added one more step. But what I'm trying to say is that we're repeating things that we've already learned. It's not like the formula is completely new. We just added one more component divided by 3 to the formula for a rectangular prism. Or we added times W divided by 3 to the formula of the area, a two-dimensional thing, a flat rectangular shape of like a rectangle or a square. So these are things that repeat themselves. We're just adding a step, and so it makes it easier to remember is what I'm trying to let you guys know. Don't be too crazy. What they all have in common is that we have to start with the area first, no matter what. So you have to find a flat surface on that thing, and then go from there. Okay, and that's always a clue of where to start when you're doing these kinds of problems, and that's where we will start. Anyway, and as always, algebra is needed. Okay, you've seen in the previous problems that we've been doing with volume how algebra is incorporated into the geometry. So, with all that said, let's get started.